Hello, welcome to the second to last lecture in this astronomy course, Astronomy 1600 at Michigan Technological University. So today we're going to go and ask the question, are we alone in the universe? Is life on Earth all there is, or is there more life out there somewhere? And one possibility of life out there somewhere is shown in this strange picture, which I will get to in this lecture, so stay tuned. First, the obligatory slides to say what is going on in case you stumbled upon this on iTunes or elsewhere. Let's see, this is an actual astronomy course being taught with actual students who will get grades. PH 1600 is the title at Michigan Tech. This is the 24th lecture, Are We Alone? Next time, the last lecture, even more fun, UFOs and pseudoscience. I have some strong views and some evidence to present there. So no dramatic confirmation that UFOs are from flying saucers from other planets. This is Michigan Tech. I am Robert Nemiroff. This is the if you're taking this course for credit, you need to go to courses.mtu.edu. If you're just finding this online, don't worry about it. Let's get rid of the check marks. So if you're taking this for credit, you're responsible for the lecture material. You're responsible for the Wikipedia articles that are entries that are mentioned each time, but not if they go into higher math. Sometimes very basic math. Algebra you're responsible for, but once the integrals start, don't worry about it. Just try to understand the concepts. You're responsible for the astronomy pictures of the day posted during the semester. So next Wednesday, 2 days from now, the next lecture is the last lecture, and so it will be the APODs up until that lecture that I will review them, and then from the beginning of the course, I think it was September 1st, but I'll check on that, till that day will be the APODs that you'll be responsible for. So you need to have done homeworks 1 through 11. Homework 12, I believe, is due later today. There will be no homework 13. What would have been homework 13 will be incorporated in the final, and so on Wednesday, which is the next lecture 2 days from now, today's a Monday, you might have guessed, the final exam will be released, and you will have a week to do it. So it will be due next Wednesday, so a week from then, 7 days and 1 hour. You'll get 7 days and 1 hour to do it. It will be due at 5. And then the next day we will process the grades, and they will be available through courses.mtu.edu, I believe, as usual. We probably won't get to the grades till later in the day, though. So the Wikipedia entries of today are something called the Drake equation, SETI, which stands for Search for Extraterrestrial Intelligence, the Fermi Paradox, and Extrasolar Planet. We'll be going over all of those today. So let's look at the Drake equation. People have wondered whether they are alone, I don't know, since space was invented. I guess modern science fiction came about maybe in the last 100 years when we began to realize there are other galaxies out there, but people have known that stars were like our sun for hundreds of years. And the idea has been around for even thousands of years. So the question is, are there any other civilizations out there? Or are we the only one? So the best answer is, well, I don't know. And that's sort of the best answer we have. But sometimes if you start thinking about it a lot, you can quantify that more by, I don't know. You can try to quantify what it is you don't know and find out where the most uncertainties are. So a famous person to do this, his name was Frank Drake, is Frank Drake. And he quantified it in this way. So n is the number of civilizations in our galaxy, in our galaxy. We haven't bought any other galaxies recently that are contactable, that we can somehow know that there is intelligent life there. Our star, so what is this? So our star is the star formation rate. So this is how many stars there will be. F sub p is the fraction of stars that have planets. So we're guessing that stars alone aren't good enough. You have to have planets, that life would form on planets. The next is the number of habitable planets per star system. I guess technically this could be included in moons. Now that moons are so popular in our own solar system as being possibilities for life, I guess is the number of chances per star that you would be a habitable place that you could, that life could develop. So then you go to the next fraction. What is a fraction of these planets or moons that could develop life? Past that, if we want to contact them, it can't just be life. It should really be intelligent life. So f sub I is a fraction of those that have intelligent life. Past that, even if it has intelligent life, it has to be contactable. So for instance, dolphins are intelligent. But if dolphins existed out around another star and there were only dolphins, we couldn't really contact them. They're smart, and they're really smart, but they don't have radio telescopes or ways to communicate with us, so they wouldn't be included. And the last thing is L is the lifespan, the expected lifespan of such an intelligent, contactable life civilization. So it could be that we destroy ourselves in a spectacular nuclear war in a couple of years. Then we would not be such an easily contactable civilization. And as the rest of the people dying of radiation sickness fought for whatever uncontaminated water there was, eventually humans would die off. And there might be another resurgence in several thousand years or 100,000 years, a million years, and there might not. But only during the time like now are we listening and sometimes broadcasting that we're here. And so that's L. So you put these all together. So here's the possible plausible values. So let's go back and forth. Our star, number of stars forming per galaxy is maybe 10 per year. F sub p, which is a fraction of stars that have planets, that's, let's say, half. So right now we live in a golden age where we're finding there's lots of planets around other stars, and some very strange systems indeed. Okay, N sub e, which you might recall, is the number of habitable planets per star. Let's say there's 2. Let's say there's lots of star zones, and so there's 2 habitable planets per star. So F sub L would be the next one, which is fraction that could develop life. Let's say they all develop life. Let's say it's inevitable. F sub I, intelligent life, that's not so common. Besides humans, well, I guess dolphins, chimpanzees could be considered intelligent. I guess we need to have a clearer definition for what intelligent is. But let's say that's kind of rare. 0.01. Let's say if the communicatability, if that's a real word, of those civilizations might be 1 in 100 again. So even if there is intelligent life. So let's see, there's chimpanzees might be able to talk, but they haven't developed communication ability, or maybe they haven't developed enough intelligence to do that. Dolphins can't. Humans can. So let's say the length of time that this occurs on Earth, let's say, is 10,000 years. Hopefully, human civilization will live well beyond that and be interested in contacting others and being able to contact others well beyond that. So maybe that's conservative. Or maybe things are just, we don't know, things will crash in some way. Global warming will get us or something. So you put all of these in and you find that N, the number of civilizations in our galaxy that are contactable, is 10. There's 10 right now. So let's talk. There's a problem though. We're listening and we're even broadcasting, but we're not finding anything. So the episodes of old TV shows, I think one of the first major broadcasts actually came out of Nazi Germany. Then after that, there was many things broadcast, including, it's quite famous, the episodes of I Love Lucy are going out there. So they're still popular today, so who knows, maybe and they're going out at the speed of light because they were broadcast from broadcast towers and radio. Nowadays, with all our modern technology, the power being broadcast has dropped because everybody's into cable and watching things over the computer. And so the broadcast power is dropping. Even in February of 2009, the broadcast type will change. Instead of just being an analog signal from towers, it'll switch over to be a digital signal from towers. But there's going to be fewer and fewer towers, and there's going to be more people that are just connected through wires. or very small wireless. So you would be wireless from you to some station that is then connected through some fiber cable to some hub. But the big broadcast towers, they're just not really working right now. They're not doing broadcasting a lot. So so we're broadcasting, we're listening. There's many SETI programs that go out and people debate, search for extraterrestrial intelligence, where to listen. One thought is in various radio bands. It might be a good place to listen. So we listen to nearby stars, and they don't have we haven't seen the alien version of I Love Lucy yet. We haven't seen any signal that we would consider alien in nature. There's always people coming up with new ideas, different ways of finding intelligent life out there. The simplest idea is just increasing the size of your radio dishes, but it's hard to. We don't have the budget to create super big radio dishes. There was a really good movie that showed some of this called Contact, based on a book from Carl Sagan, one of the big popularizers of astronomy, who died a few years ago. And in this movie, the woman that actually is at the Very Large Array of Radio Telescopes, which is not the largest collecting area, but you can search with anything. It looks most photogenic. So theoretically, if you were to point it in the right direction, you might pick out something that no other radio telescopes. It's possible. Probably the biggest one, though, is the Arecibo telescope. Is the biggest radio telescope in Puerto Rico, and that is used sometimes to search for extraterrestrial intelligence. That is a very, very big dish. It's a very sensitive collecting area, but it looks at a very small part of the sky. Many times, I used to do this. I analyzed data from the Arecibo telescope right on my home computer. And I'm not special. I was one part of thousands of people who use something called SETI at home and downloaded their programs. And so that when I wasn't using my computer and it went into screensaver mode, it would download packets of data from Arecibo through a hub site in California, I think, at SETI at home, and my computer would crunch away at it. And it would send back packets and of what's been found. And to the best of my knowledge, they never found any type of extraterrestrial intelligence in those signals. They found some unusual signals, but nothing that was verifiably extraterrestrial. And I'll talk about that as we see in the future slides. I'll review some of this as we see pictures of different things. So let's get down to, so we haven't seen anything. 10 expected, none found. So what is that? Well, scientific jargon, it's a 3 sigma difference, almost 3 sigma. So we don't see anything, and that's sort of called, we expect to see alien civilizations, and we don't. And that's called the Fermi paradox, after someone, I think it was Enrico Fermi, a famous physicist, who said, well, where are they? Okay, everyone's talking about UFOs, extraterrestrial civilizations. Where are they? Don't see them. So something's got to be wrong. And it's really cool, actually, to go to the Wikipedia article on this. There's one of the better discussions I've ever seen, is different ways of, different solutions to the Fermi paradox. Some of them are really bizarre. Like, are we part of a interstellar zoo where we're allowed to be looked at, but we're being protected and not contacted by extraterrestrial civilizations? So I find that, I don't know, maybe a little bit far-fetched. Maybe the time of broadcasting, maybe civilizations destroy themselves much faster than 10,000 years. That ultimate power corrupts. There's never been a powerful weapon that hasn't been used. So as we develop more and more powerful weapons that are incapable of destroying us, it'll destroy us. Interesting, actually, there's an interesting point made by Heinlein. Colonization of the moon actually has dangerous military consequences because a catapult can be built on the moon, and was in Heinlein's story. And so the moon people broke off and declared independence, and that's fine, I guess. They can declare independence. But they're close enough to Earth, and their gravitational field is so low that they can just launch rocks, and they can rain down on Earth, and that's not fun. Okay? So maybe something like that happened, or happens. Okay, there could be life in our solar system. For instance, Mars. Now that we've seen that there's these blocks of ice well away from the poles even, there's water ice near the poles. So who cares about water ice? Water ice is thought to be one of the tracers of life. That if there's water ice there, that's an indication that there could be life. Well, there could be other kinds of life. Maybe we're only looking for our kinds of life. So we are very liquid beings. Most of people are liquid. Not only that, but liquid is a good way for cells to move around. And we have experience seeing that life can develop in a liquid environment. So we search for what we know. Is it possible there could be other ways, not water, involved in creating life? There could be life forms that are not involved in water and carbon, because we're made of carbon too. Yeah, it's quite possible. Oh, speculation runs rampant, though. I don't know. Yeah, what would they look like? There are interesting science fiction stories that sometimes explore what could be an even more vast landscape of things like that. One of them is called Dragon's Egg, if you want to look that up, which is life that develops on the surface of a neutron star, and it lives 1 million times faster than we do. Things just happen there much more quickly. The gravitational field is much more strong. The magnetic field affects the way these beings move, and it's really cool. It's by Robert Forward. So you can look that up. There's many other interesting speculations, though. On Mars, there could be, since we have blocks of water on Mars at the poles and now known to be elsewhere, also we have recent evidence that Mars underwent several periods where it was wet and they had seas, oceans maybe, over part of the surface. So maybe life developed on Mars. There is an hypothesis that life did not develop on Earth. Life developed on Mars, and due to Mars's relatively low gravity and big impacts, things get thrown up into the atmosphere. So it's possible that single-cell organisms evolved on Mars back when it was wet, and Earth was inhospitable, violent with volcanoes and things like that, and molten rock. So then life developed on Mars. Big rocks hit Mars, threw stuff, some of the rocks with life on them, out into the solar system. Most of them fell back to Mars. Others continue in the solar system today. But some of them, some small fraction, fell to Earth and seeded life on Earth. It's a possibility. So maybe life developed on Mars. Maybe we're all Martians. But the going rate is that life developed here on Earth and not on Mars. But we still look on Mars to see if there's any life, although scientists don't like to talk about that, or if there's any indication that there could have been life. More recently, the exciting possibilities are that there could be underground seas in Jupiter's moon Europa. And Freeman Dyson once speculated that if that was true, and again, you have these big impacts that happen every now and then, maybe some of the fish that swim there were thrown out into space and froze. So maybe the best place, or a good place to look for life, is by looking for frozen fish orbiting Jupiter. So here you get the wild speculative kind of arguments that kind of make this kind of crazy, this life in the universe stuff, and sometimes make it kind of fun. Sometimes it puts it outside the realm of real science. It's difficult to detect fish around Jupiter. But you don't know that when you come up with the idea. You can start thinking about it. Well, what would it take? And only after you estimate it, you find out that we really can't find that out just now. Titan, moon of Saturn, very interesting. It has a liquid on its surface, but it's not liquid water. It's hydrocarbons, ethane, methane. It rains there. Maybe that's the most important thing for life. It's got lots of carbon. So we landed something on Titan, and nothing came up to the spacecraft and tried lifting it up and seeing what it was, or eating it, or posing for it. Still, there seemed to be rocks made of frozen water. So there seems to be a lot of volatility, which might be important for life. But we don't have any first-hand evidence that there's life there. Even more recently, Enceladus of Saturn, another moon of Saturn, is shown to have it's spewing some kind of freezing water, whether it was water before it froze or whether it's just ice always. Whether there's underground seas, we think there are. Does anything live there? Don't know. But these three places are key places in the solar system that humanity is considering sending more and more spacecraft: Europa, Titan, Enceladus. And one of the drivers for that is to see if there is life, or the conditions were ever ripe for life there. Anywhere else? Well, Carl Sagan once estimated that let's get away from these classic conservative attitudes that life has to be water-based and walking on ground. Possibly there could be these big beings that float around in the cloud tops of, say, Jupiter. And maybe they are these big balloon things that take in gas and release gas to go higher and lower. So they're living balloons, and they communicate with each other, possibly by manipulating somehow the electric charge on their surface to send out radio waves to each other. Could it happen? It's still possible. It's just not life like we know it. So we do get some kind of radio noise from Jupiter's atmosphere, but it's nothing coherent that we can tell. We think it's related to lightning. But they wouldn't be broadcasting so loud. Just some thoughts. Okay, this is, now we get into a nice picture exhibition. Here we are on pictures from spacecraft Mars Express orbiting Mars. And this is a crater near one of the poles. And inside this crater, there appears to be water ice. Although I believe this is a false color image, there is clear indication that there is water ice there, and it's not melted by the sun. I'm not sure how long it's lasting due to the thin atmosphere of Mars. So I'm a little bit confused by that, but it's possibly seasonal, just like the ice caps are. This was taken a couple of years ago. There are these strange blocks here. And it was thought that these blocks are ice, water ice blocks covered with Martian soil now. That conjecture has been bolstered by recent evidence from this. This is just recently the Phoenix lander on Mars. I apologize, actually I got this wrong. It says Phoenix and the Snow Queen over here. Credit Kenneth Kramer. APOD 2008, June 12th. So when Phoenix landed on Mars recently, this year it sent back a lot of images. And here's an image looking down at its own footpad. This was a robotic thing. Here you see some springs to cushion the drop. I think this is a shock absorber. But this is interesting. This is a piece of the spacecraft that came off. That's okay. This is interesting right here. That looks to be, and we think is, ice. So it used to be covered with this stuff here, but when the spacecraft landed, it created local winding effects, which will happen when you land your spacecraft. You should expect that. It wasn't. I didn't hear speculation beforehand that looking right under the spacecraft would be a good place to look for ice. My understanding is they'd look for ice around it, but it turned out right under it was a good place, and right there, it didn't have to look beyond its own feet to find water ice. And it found other pieces of ice around it, covered with smaller pieces covered with essentially Martian sand. So it's ongoing data analysis to see if the boundary between these, the ice and the sand, could ever have been conducive for life. I've heard speculations in both directions. Even more recently, this came to light just last month, where radar from, let's see, from which one is it? One of the Mars missions that's orbiting Mars found, I think it's Mars Reconnaissance Orbiter, but I'm not sure. Looked at and found strange structures here in the craters. And with the radar, they were able to understand that most probably what they're seeing there is big glaciers of ice covered by Martian soil. And the Martian soil prevents these glaciers from sublimating, from essentially evaporating into the air. So if you were to go pour water on Mars, it would evaporate. You would freeze possibly first and then evaporate. That's what might have happened here. Even if you poured water on Mars here, it would freeze and evaporate here, which it probably has done. but it might have left a residue. Maybe that water, maybe there was a hole here, and there was water that had some kind of white stuff in it. And so when it froze and evaporated, it left the residue. And that is speculation for what some of these deposits are on Mars. If that's true, it's even more exciting, because this shows that not only is there frozen water on Mars, but there's liquid water in parts of Mars. But it's always buried. That's also important for if astronauts. So pretty much every recent administration that I can remember decides that that one cool objective would be to send astronauts to Mars. It then becomes realized that this is prohibitively expensive. I guess many presidents like to emulate the John F. Kennedy announcement that we're going to land a person on the moon and recover them within 10 years. And spectacularly, with a budget that was tremendous, that was accomplished. The announcement was in 1960, I think, and it was accomplished in 1969. Neil Armstrong set foot on the moon. Tremendous. But the kind of budget that went in there was a national prestige budget, because it had never been done before, and the Soviet Union was thinking they were going to do it first. And so the Soviet Union had also just launched Sputnik, and so the US, which previously had prided itself on being the technological leader of the world, now appeared to be this puny second place. But President Kennedy realized that we could reclaim this, not just reclaim this by landing a human on the moon and recovering them. So he gave, lots of money, many billions of dollars to accomplish this. And it was done. And we beat the Soviet Union, and we just barely beat them. They had landed rovers on the moon that were rolling around. The Russians the Soviet Union hit the moon, I think, in '57. They just hit it with a rocket that didn't break. And it exploded with little tiny capsules that said CCCP. And I don't know, maybe that was a claim for the moon. But I don't know. Nowadays, presidents will try to land on Mars, but there's no national prestige budget involved. There's only a science budget involved. And national budgets will dedicate less for science than they will for reclaiming national prestige. So on the science budget, it's tough. It's tough to land humans on Mars and get them back. But there's still lots of cool stuff that can be done. It's also relatively expensive to send people. Because people, if they die, that's really bad, for one thing, because you don't want to kill anybody. Lots of people would volunteer to go, though, even if they knew they would die. So one of the early ideas of sending people to the moon was that why bother trying to bring them back? It's too expensive. Let's just leave them there. And people would say, well, who would want to go and be left there? And so I think there was an informal survey, and there were people who would line up and say, leave me on the moon. I want to go. I don't care. The problem with that, in my understanding, is publicity. That once the person gets to the moon, they might change their mind and decide they want to come back, but we don't have the technology to bring them back. Not only that, but their relatives are going to show up on their local news station saying, please bring them back. They're going to die, right? And it's a public relations disaster. So they have to bring them back, even if they want to go and stay. So that's expensive, because people need to be within a certain temperature range. They don't like it when it gets too hot or too cold. They constantly need water. They have to pee and poo and things like that. And they get hungry. But if you spend a robot, you don't have to do that. Robots can undergo much different extremes. They don't have to constantly eat and pee. And so you can get a lot of the science return. Not all. You can get a lot of the science return from robots. But in sending humans, there's another reason to send humans, in that there is a science fiction-propelled manifest destiny that humans should get off the planet and live elsewhere. And that would be great. It's tremendously expensive, but it would be great to do that, to establish colonies elsewhere in the universe, where there's not just humans on Earth, but there's humans out. And then we'd have, instead of airplane rides to other countries, you can have rocket rides to other star systems. That would be great. And that is a wonderful goal. The problem is the scale of budgets. The scale of budgets to send space probes into the solar system is much lower than it is to establish human colonies there. And the amount of money that, in terms of percentage of gross national product of the United States, is much better suited for the robots than it is to establish the space colonies. But still, prices are dropping. There's private launches of rockets now. This could happen. The price of establishing colony on the moon or on Mars drops by certainly a few percentage points, a year. And it might soon come within the realm of a reasonable percentage of the national budget to do that. Maybe not, but I remain hopeful. Fortunately, it is still within the realm of a few percent, or less than 1% of the national budget, to send space probes, which take pictures like this, and which might help figure out where to send humans in the future. That's my view. Okay, so here's this famous first picture. So it turns out that sometimes you don't have to go to Mars to examine Mars. Part of the idea of going to Mars is that you could get out, pick up rocks, and inspect them. You could send a spacecraft to Mars to scoop them up and bring them back, but it's easier just to put an unsophisticated laboratory on there and look for life, which we did with the Vikings in the 70s, and we got ambiguous results. And Phoenix is now hasn't clearly found life, but those results will be coming out. But it turns out that if you wait long enough, space will come to you. So there are all kinds of rocks floating around the solar system. Some of them came off the Earth. Many of them were just broken off of comets or asteroids, and they fall to Earth. But some of them came from planets. And we know now what the composition of Mars is. So when we pick up rocks, we can compare the composition of the rocks to what composition of Mars is compared to composition of the Earth and other things. And now we've found some rocks that we think they're from Mars. So they got there because, again, big things smashed into Mars and threw rocks up, and they came down on Earth. And so what happens is people say, okay, well, let's look for some of this life now. And so they slice it open, and they look for stuff. And usually they just find nothing, or they find boring stuff. But sometimes they find something, and here's something they found. This is maybe 5, 6 years, 10 years ago, 11. Made a big splash. Aliens found on Mars here on Earth. Crystallized. These are not actual life material. This is rocky material. It's like, happens to trees. I'm missing a word. Petrified. There we go. So it's rock where it was once something else. But this is controversial. This is still controversial. People today are not willing to say this is a petrified life form. This is a micrograph, a very small being, if it ever was one. It looks like some small microbes might look on Earth. But we don't know really what it is. It could just be an unusual rock formation. Here's some more. What are these? Titan. Again, we landed something on Titan. Titan's a bit mysterious because it's the only moon with lots of clouds here. Taking infrared light, you can see through the clouds. This could be methane seas, not always damp. It probably rains. A good place to find life. Here's an artist's rendering. This is not a picture of what methane rain might look like on Titan. There's an interesting industry that's growing up that we tap into on APOD of people who realize that we don't have pictures of the coolest places, but these are really interesting places, and so they come up with what it might look like. So it's art that's done as scientifically accurately as possible, which is a pretty cool concept. Usually too many things are happening in the same frame to get it in, but that's okay. Here's a real image from Cassini that has the ability to bounce radar off things. And so it bounces radar off of landscape and says, okay, there's landscape there. But then it bounces radar off here and nothing comes back. Why didn't anything come back? Well, one possibility is that this is really, really smooth. Why would something be so smooth? Maybe it's a lake. So it's another indication of methane or ethane lakes on Titan. Okay, on to Enceladus. Again, we've seen this before. These are tiger stripes. They appear to be expelling plumes of fine ice particles. And the question is, how does that connect to what's below the surface? Apparently there's some compression, I think it's tidal compression of Enceladus, which heats it. And there might be an underground sea that's emitting these things. So here we see what we think could be this vapor. It's not really vapor, it's ice particle vapor coming off in the dark parts. We've seen this image before too. And here is one of the tiger stripes. Here is a picture looking back toward the sun. I don't know exactly where the sun is here. It's maybe just off the screen over here. So here's a very slim crescent of Enceladus. Here you can see the forward scattering of lots of the ice there. So it's clearly, there are lots of streaming ice venting from this moon, which indicates there could be underground seas. Here's an artist's rendering of what it might be like to sit on Enceladus and look at Saturn as it rose. And here you see ice plumes, Saturn, cool visual terrain. It's just an image, but it's just a artist's rendering, but it's pretty cool. Could be accurate for all we know. Okay, searching for life. This is the very large array of radio telescopes in New Mexico. And it is, all of these look at the same time, and the reason, so you can spread these out, they're on train tracks. I had the good fortune to actually, you can walk in these. So they're about the size of a classroom, maybe a little, yeah, about the size of a classroom. You can walk in there. They do a lot of regular radio astronomy, but sometimes they search for extraterrestrial life, very rarely. But it was the topic, that was the device of preference because of how photogenic it was in the movie Contact. This is how big it is compared to a person. Here is a person, and here is a dish at the Very Large Array. This is Arecibo, which is actually more commonly used to search for extraterrestrial life. Again, it's not its primary mission. Its primary mission is radio astronomy, trying to figure out things about the distant universe and the nearby universe. But sometimes there are observations approved for searching and even broadcasting once for extraterrestrial life. This is one of the first instruments used to look for extraterrestrial life out in the universe. It's called the Big Ear. I don't think it still exists. I have a recollection that it was at Ohio State. I should have checked that before giving this lecture. I used to know that. I think this was run by Frank Drake, who came up with the Drake equation. And so the strange news is that soon after it was turned on, it detected an amazing signal. And it's called the WOW signal. And so the question was, even sometimes debated today, was that a real signal? People looking for it later with other radio devices were not able to see it. It does not repeat so far as we can tell. Hypotheses are that somebody might have been playing a trick, thinking that, oh, he thinks he's going to find ET, let's give it to him. And they went out with some kind of device and set him up. It can be sometimes as easy as turning your car on and off with the ignition. Unclear whether that was a signal. Unfortunately, in science, we need to have things verified. So it needs to be seen usually by more than one research group. And this was not, and in more than one time. This goes back to SETI at home, how anyone can, I think you can still search for aliens. So if you want to search for aliens, you can. When you get back to your home computer, download SETI at home. Search for SETI at home through a search engine like Google. It'll be the top hit for sure, one of the top hits. Click on it, download the software. Then when you're next out shopping, your computer could be searching for aliens. It is commonly thought, and perhaps I do this myself, that all signals are understood, and that none of them can possibly be extraterrestrial. And that's not true. There are signals that we see every now and then that we don't understand. They're not verifiably extraterrestrial, but we don't understand what they were. They could have come from an extraterrestrial origin. And here we see something that came from one of these SETI searches for the SETI League. This is a plot that shows that there was this, what seemed to be this carrier wave that was drifting. It could be some part of the sky. A lot of times when you want to communicate something, you just do an on-off, on-off, and then you vary the on and off a little bit. In amplitude, it would be amplitude variation. In frequency, it would be FM band frequency variation. So this is a possibility. We don't know what this was. I've heard analysis more recently of this particular event is probably thought to be a military satellite, and the military just doesn't confirm it. So some military satellite went through the beam of a radio telescope that was searching for extraterrestrial life. It's usually pretty quiet, but since these things are very sensitive, it might have picked up some kind of onboard carrier signal. We think, oh, good, we found it. Military probably knows, no, that's not it. But the military doesn't want to say where their satellites are. So there are sometimes misconceptions like that. So we don't know what this was. The scientists don't know what this was, for sure. Sometimes weather satellites can do that, too. Sometimes partially defunct satellites can do that. Okay, this is the Voyager message in a bottle. So the Voyager missions that went out to the deep solar system, they had these big disks attached to them. And these disks start telling us, potential aliens, what humans might be like. This is how to find us based on nearby pulsars. So it is hoped that the nearby pulsars would be seen by nearby extraterrestrial civilizations, and they would know what those are. Oh, yes, that's the pulsar that blinks this fast. And that's this one. Here's a pulsar that blinks that fast. So, oh, these people are saying they're there. Oh, okay. Now we know where to find them. So I think Carl Sagan was involved in sending this, and he was sued. Because it turns out there's people who don't want extraterrestrials to know where we are, because they might come and hurt us. So but I think it was thrown out of court. So this can get strange. Okay? Okay. This was a message from Earth, again, Frank Drake. Beamed this out with a team. Beamed this out, et al. Tells you it's the team. Beamed this out of the Arecibo Observatory, I believe, at one of the inaugural events of the observatory. And this tells, I think it was beamed toward a globular cluster. People or some intelligence in the globular cluster, what's going on here, that we're here. So this tells us, I think this is binary. This tells binary. This might be 1, 2, 3, 4. No, this is 0, 1, 3. This would be 4, 5, 6. This says that we're talking about binary numbers here. This tells the solar system here. So we're the third one out. This is a picture of a radio telescope. This is a picture of a human. This is DNA. I couldn't figure out what that was. I don't think they could either. But if you read what it is, there is a real basis for what's being explained there. It's sometimes fun to try to sit down with some of the messages that are broadcast and see what you can figure out and what you can't. This was not the only message sent. This is another one called the Cosmic Call. And this is cool to figure out. I sometimes have assigned this for homework. Figure out what's being said. And it's just a lot of numbers faced by a really big prime number at the bottom. It's pretty cool. It seems impossible to tell. Okay, so first of all, how could an alien civilization know what's going on? How can they get this picture? How do you beam a picture so they know it's a picture? Well, the one way you do it is you have a prime number of pixels in this direction, and you have a prime number of pixels in that direction. And then you send out a bit stream that is the multiplication of two prime numbers. And the idea is that they're supposed to figure out that it's two big prime numbers. You keep repeating the bit stream so they'll know. And once they see two big primes, they say, oh, okay, you're talking about a two-dimensional image that's one prime by the other prime. And then they turn on and turn off pixels based on the broadcast, whether it's a hot pixel or a cold pixel. And hopefully they can build up something like this. Could be they couldn't even figure that out. Not because they're stupid, because they just think differently. Globular cluster, M13. This is where the message 2 ago was supposed to go. But the broadcast team did not account for drift, proper motion of the globular cluster. So they missed. But they still got the outskirts. We can practice looking for life right here on Earth. There are areas that are almost disconnected from the current life environments. And what's really cool is in Antarctica, there are these underground lakes. And these lakes are, so here's the surface, here's the lake. It's warmer under there than it is on the surface. And so this is water. Some of this is ice. This is mostly ice. There could be rocks. And so there's an underground lake called, well, there's several of them, but one of the famous ones is Lake Vida. And people are now wondering whether there is any ancient life down there. So this is just a weather station. There was a National Science Foundation experiment. I haven't heard the results of this. I have to go check on this. That was digging down into Lake Vida, not wanting to contaminate it, but just wanting to draw off a tiny little bit of it and analyze it to see if there's any microbes or anything floating around in there. That would be really cool, because it would have evolved probably well differently than, you know, the interconnected life that occupies the surface of the Earth. So they're checking on that. I don't know. They might have found nothing clearly alive down there. But it shows that we can practice looking for extraterrestrial life here on Earth, and that many of the ways of drilling through the surface and trying to take up a little bit and analyze it is things that might similarly be done elsewhere in the solar system, were we to launch things to Enceladus or not Titan, what's the other one? Not Ganymede. Europa, thank you. So yeah, so we're practicing looking, and who knows what we could find. Turns out humans are not the best astronauts. Humans tend to die and stuff. But there are some microbes, like D-rad is you can look it up. It's got a fancy name that's really long that would impress you but wouldn't be meaningful to you. Here are some in a test tube, in a dish, petri dish. These things are really hardy. I think they double check somehow their DNA when they reproduce, so the high radiation doesn't seem to bother them. Hot doesn't bother them, cold doesn't bother them. I think they were discovered during process of trying to clean food, trying to create a cleanly environment, supposedly a completely clean environment that is free of all bacteria. Well, when doing that, turns out you're not able to kill all the bacteria all the time, and if this stuff is around, you got a problem. This stuff isn't going away so easy. So then the idea is maybe these would make good astronauts, because they can survive where humans can't. So maybe sending humans to Mars is the wrong idea. Maybe we want to send this stuff to Mars because it could probably survive there, or similar stuff. By the way, the answer to is there life on Mars is yes. And the reason is because we put it there. Because there's things that have crash landed and landed on Mars that were not decontaminated. And even stuff that has landed on the moon has, on the backside, outside of the radiation field, has indicated, when Apollo 12 visited Surveyor 3, they looked to see whether microbes survived on the underside of Surveyor 3, and they found out they had. So the answer, is there life on the moon, is yes. And the reason is, surely we put it there. Did life develop on the moon? Well, probably not. Is there life on Mars? The answer is yes. Did life develop on Mars? We don't know. But we put it there. And there are science fiction stories about that, too. So here we have people, I think I showed this one before, looking for pieces of Mars, say, or maybe even Mercury, if you saw the movie 8 Below, which is really good. These people have their snowmobiles, and they're going over the blue ice looking for unusual rocks that are just out there out of nowhere. How did that rock get there? Well, it's most likely a meteorite. And so you look at the composition of it, most likely it's from somewhere on Earth or something, or it's from somewhere in the solar system. But every now and then you find something that looks like this, and it's from Mars, we think. And so we can analyze it and look at it in some detail. Lots of planets out. I have to zoom up. So one of the main pushes in modern astronomy is to find planets out in the universe. And in the past several years, we haven't been able to go there, but we've been able to detect planets due to slight wiggling of the stars. We're able to detect these wiggles in more sensitively than ever before. So several systems. Here, this 55 Cancri, relatively nearby, has at least planets. Don't know if there's a moon like that. The innermost planet of Gliese 876d, around a sun-like star, might be a tremendously difficult place to visit, but with all its flowing rocks and volcanism might develop life. Here we have the first known multi-planet star system around a regular type star, and this, at least 3 planets are known, B, C, and D. I don't know what happened to A. This is not the star. The star is tremendously bright, and they had to block it out, and they had to block it out digitally, and when you do that, you get noise. So you can't, the noise, so what you're seeing is the noise that remained after they tried to block the star out. But you can see the planets that are glowing in infrared light. And sometimes they reflect starlight significantly. There is a claim of water vapor around this star and a distant star in a planet. So here's a planet that's much, an extreme version of Enceladus is dripping water vapor. And as it goes in front of the star, you can see the water vapor absorbed here. And so they think they've seen that. So there's evidence of water-bearing planets in stars well outside of our sun. Which brings us back to the original image. The quest for life out in the solar system and the universe is just getting underway, and will surely be a rich field that will involve both astronomy and geology, yes, and biology for certainly the lifetimes of everybody watching this. It's a very exciting thing to contemplate and to look for. And tomorrow, next lecture, we will do the last lecture, and we'll do pseudoscience and review the last APODs. So I'll see you then.